Okay, so now we find the potential energy for spring. Spring force is a conservative force, we have already discussed. Okay, so we have to find the potential energy for spring. Now let's say we have a spring over here and this is the block. Okay, and this is the natural length of the spring. If I take the block over here and I release it, as the block goes back, spring will do some work on the block, correct? And the kinetic energy of the block will increase. So what we could say, I have moved the block against spring force. So now the block has a tendency to gain kinetic energy, correct? I have moved the block against spring force. So as I release the block will gain kinetic energy. Fine. So as I move the block against the spring, I have increased the potential energy of spring and block system. Okay. As I move the block against the spring force and I release it, spring is trying to pull it back. So I could say that spring plus block system has increased potential energy. Fine. So if this is at x distance over here and the block is over here, then let's say for example I have the spring over here, right? As I pull the spring and I release it, you see it simply went forward. So right now the spring and the block system, this is your block over here and this is the spring. So the spring and the block system has some potential energy. As soon as you release the system, it gains kinetic energy, correct? So in this position the block and the spring together are having some potential energy. Okay, I told you potential energy is defined for a system. In this case the system is block and the spring. Clear? So how do we find the potential energy of spring? Now we know the formula, delta U conservative equal to minus W conservative, correct? So if I move the block from x equal to 0 to x, I move the block in this direction. What is the potential energy? We already know the formula for work done by spring equal to minus kx square by 2 when the spring is elongated from 0 to x, correct? So delta U spring equal to minus of work done by spring equal to kx square by 2, correct? This is the change in potential energy of spring plus block system. So I could write down U at x minus U at 0 equal to kx square by 2. Okay. Now the interesting thing about potential energy is that we are always interested in change in potential energy. We don't care about the actual value of potential energy. So the thing is, we could take any point with reference. We could take any point as 0 potential energy. So in this case, if taking U0 equal to 0, we could take anywhere potential energy to be 0. But in this case we are taking U0 equal to 0. Why? Because this makes our formula easier. Okay. So we will get Ux equal to kx square by 2. This is the potential energy. Okay. Now, so we have found the potential energy of a spring where x is elongation, correct? So if spring is elongated, then potential energy is kx square by 2. What if spring is compressed? If spring is compressed, then we could say that elongation is negative, but square of negative is positive. That means whether you elongate a spring or you compress a spring, in either case potential energy increases. Okay. Now where is this potential energy stored? You see, when I move the block, what has changed? Has the shape of the block changed? No. Has the mass of the block changed? No. So there is no change in the block. Block can carry energy in the form of kinetic energy. Energy of block will be in form of mv square by 2, which is kinetic energy. The block cannot carry any other form of energy. When I elongate the spring, something is changing. What is changing? The length of the spring. Okay. So this potential energy over here is getting stored in the spring. Okay. So we write down that, note down this thing, potential energy of spring is stored in the spring. Okay. The block can only have kinetic energy. The spring is changing its length, so the energy over here, potential energy, is stored in the spring. See, I told you, right? Potential energy is depending on position of the system. In this case, spring plus block system. As you increase the length of the block, the spring has elongated, the position of block has changed. Correct? Now, so the energy will be stored in the spring. Clear? One more thing now. Why not the block? There's one more reason for that. See, I have mentioned the mass of the block over here. No. Correct? To mention kinetic energy of block, we need mass, mv square by 2. But to mention potential energy of block plus spring system, I have only k and x. K is the spring constant, x is spring elongation. So these are all the parameters of the spring. So the energy will be stored in the spring. If I have got a mass m or I directly pull the spring, in any case, the spring potential energy will be stored in the spring. So the potential energy here is depending on the elongation or compression of the spring. Clear? Now, one more thing. Let's come back to gravity. This is the object. When I take the object away from the earth, potential energy has increased. Correct? Where is this energy stored? Earth is not changing. The block is not changing. Configuration of block has not changed. Configuration of earth has not changed. What has changed is the distance between the block and the earth. So the potential energy, the gravitational potential energy, is stored in the extra space created between them. Right now the block is here. When I take the block over here, the space between earth and the block has increased by this much amount. Okay, this much amount. So in this space, the potential energy of gravity will be stored. Difficult to understand, but try to digest it slowly. Okay.